Hi, everyone. Welcome to another Clean Machine Live. My name is Geoff Palmer. I'm CEO and founder of Clean Machine, plant-based fitness nutrition. Before we get started, just remember that this video is for informational and educational purposes only. It is not intended to diagnose, treat, cure, or prevent any disease. Okay, so we're going to talk about protein here. One of my favorite subjects. Being a plant-based athlete, being vegan for 38 years, and turning 60 this year, and still maintaining a monster physique for a completely drug-free athlete. How do I do that? You obviously, muscle is made from protein. But what does the research say? Well, this is an interesting new study. Let's go ahead and pull up the study, share the screen, and let's see. Let me switch the tab here. So this study is called Nitrogen Balance at Recommended Dietary Allowance for Protein in Minimally Active Male Vegans. So it's a pretty interesting study because, one, it's in male vegans. That's unusual. But they were looking at, since the popularity of vegan diets has increased in recent years, and that the RDA is at 0.8 grams per kilogram. So let's take a look at that, what that actually means. 0.8 kilograms per kilogram, if you're an 80 kilogram person, or basically 176 pounds, that would be 64 grams of protein. As you can see here in their diet, they have 64 grams of protein per day for the group of vegan men. Now, I did think it was kind of interesting that they have an apple here at 0 grams of protein, they have pineapple here at 0 grams of protein, they have mango here at 0 protein, and fruit snacks at 0 protein. So they got 4 different parts of the daily intake at 0 grams of protein. And then they threw in a protein shake in the first one. So what did they find? On day 5, well, let me first discuss this is a small study. So 18 minimally active vegan men, and it was only for a short period of time, 5 days. So it was a eucaloric diet, which means it was a maintenance diet. That is just basically about the same amount of calories that would maintain their normal body weight. So what the findings found was that on day 5, their urine was collected for nitrogen balance, and they found that they had a very small but negative balance in absolute nitrogen balance, and the mean relative nitrogen balance was actually significant. It was 18.6% drop in nitrogen balance. Now, what does nitrogen balance mean? Well, nitrogen, so carbohydrates, fats, sugars, even fiber are all CHO, carbon, hydrogen, and oxygen. The difference is when you add a nitrogen molecule to that, you can create amino acids and proteins. So when they talk about nitrogen, that's a clear way of detecting the difference between calories from protein or calories from carbohydrates, fats, or fiber. Okay, so nitrogen means basically protein. It's a placeholder for protein. And nitrogen balance is when you are breaking down as much protein as you're rebuilding and replacing. So that's called a net zero or nitrogen balance. Now, we constantly have nitrogen turnover. Nitrogen turnover means our body is breaking down cells all the time and replacing it and repairing cells as they are faulty, as they need to be replaced, as they age, as they get destroyed from injuries, things like this. Our body is in a constant state of nitrogen protein recycling and protein turnover. Okay, but when your intake of nitrogen or your intake of protein and amino acids is at one level, and then your output, that's how much protein is leaving your body in nitrogen, that's collected through the urine. And you can see if there is a negative. If there's a negative, it means you could potentially be losing muscle tissue because you're not feeding enough protein to meet the requirements of the body. Okay, so let's look at the next thing. So the RDA, the current protein recommendation, is 0.8 grams per kilogram. So at 0.8 grams per kilogram, someone my size and weight would intake 64 grams of protein per day. So I weigh about 180, which is close enough to 80 kilograms is about 176 pounds. So that's roughly about that. Now, that would be low for me. And yes, I have tried going that low. And I did find myself losing some muscle. Now, you also have to keep in account the understanding that once you gain age, once you get past 50, and even more importantly, past 60, your body actually tends to need a little bit more protein than normal. Now, then there's the other thing. There's many studies out there showing that absorption is a little bit different, a little bit less in plant protein. One study measured that between chicken protein. They took chicken breasts and they compared it to the absorption, and they found it was about 2% difference. So not a whole lot. And if you're eating sufficient amounts of protein, that should more than make up for that. Okay, so let's take a look at this next study. Let's see if I can put it up here on the screen. Let's see how I do this. Sorry, this is new for me. I'm just learning this Restream. And let's see if I can find, let's see, a share screen. And let's see if that works. Okay, so here we have 80 kilos is 176 pounds, and that at 80 kilos, that would be 64 grams at 0.8. That's the RDA, 0.8. Now, most of the studies for athletes, people who are exercising regularly, they focus on 1.6 grams per kilogram, and then that would be about 128 grams of protein per day for a male. So at that level, they find not much more than that. Maybe up to 1.8 is about maximum amount of protein, 1.8 grams per kilogram of protein intake is about a maximum amount that will increase the amount of protein synthesis or muscle gains. Anything more than that, you're just wasting it or adding extra calories to your body's intake. So also want to call out Garth Davis. Thank you, Garth, for posting this. Garth has written a good book. Dr. Garth Davis has written a good book called Proteinaholic, really investigating some of these things. But this is a brand new research, just came out 2023. You can see this July 2023 study. And so what we're looking at here is okay, so you got a couple of factors going on. One, slightly less absorption of plants' protein. Two, you've got needs for athletes to be a little bit higher, or people who are exercising with intensity a little bit higher. Three, people who are aging need to be a little bit higher. If you're male, you need to be a little bit higher than women. And then finally, the amino acid profile is slightly different too. Plant proteins tend to be lower in the branched chain amino acids, specifically leucine. Now, leucine actually triggers and helps initiate mTOR. mTOR is the machinery that the body uses to create new proteins. And we need that for building muscle. So leucine, think of it this way. If you've got the cell, it's got a docking station on the outside for insulin. When insulin docks to it, it allows the body to pull in fats and sugars, carbohydrates and fats, get them into the cell so that the body can utilize them for energy. All right. Similar to leucine, protein and the leucine actually acts kind of like insulin. It docks to the outside of the cell and triggers the cell to pull in amino acids. So leucine can be a catalyst to trigger the process of muscle protein synthesis. Okay, so let's dive into that a little bit. All right, so first off, all essential amino acids come from plants. Animals don't make them. There are a few bacteria that actually can create essential amino acids, but we don't eat bacteria for lunch, dinner, and breakfast. We eat plants or animals. But all the animals get their essential amino acids from plants. So they all originate. This is how they're made. The plant takes in sunlight. It pulls in carbon dioxide, that's the carbon and the oxygen that it needs, and then it pulls in water, which is the hydrogen and oxygen it needs, H2O, and then you've got carbon, hydrogen, and oxygen, or CHO. CHO is carbohydrate. That is what glucose, that big ball in the middle, it is a glucose creating machine. So everything pretty much is made out of glucose as the backbone. Starch is made from glucose. Fat is made from glucose. Carbohydrates, glucose. Even amino acids and protein start out as carbon, hydrogen, oxygen, and then nitrogen added to that to CHON. So now you've got 4 different molecules in there: carbon, hydrogen, oxygen, and nitrogen making the proteins. So this is how all the amino acids are made. All right. So plant proteins versus whey proteins. These are a couple of interesting studies. So they looked at 8 weeks of whether whey protein or rice protein on the body. And they found in the study there were no differences between the 2 groups. Okay, so that was pretty interesting. That they said, well, maybe that's just a one-off. Let's take pea proteins and see what happens. So they look at pea proteins, and you can see the study there, placebo-controlled clinical trial, pea versus whey. Well, the conclusion, this one actually was pretty surprising. They found that the muscle thickness increases were significantly different. The pea protein actually was about 33% more muscle thickness than whey protein. Now, why would that be? All right, so to understand this part of the equation, we have to dig into the next part of the slide. So they looked at a broader study, and they looked at a big amount of people, thousands of people, and they found that there were no associations between clusters, that's the type of protein, and any musculoskeletal outcome in adjusted models. Now, the caveat was that as long as you were eating sufficient amounts of protein, there was no difference between plants or animal sources. As long as you were getting enough, the source of the protein did not matter in the outcome of how much muscle you could build. It did matter if you did not consume sufficient enough protein, which you can see at the bottom there. Individuals in the lowest quartile, that means those in the lowest group of protein intake, had significantly lower muscle mass. So if you do not eat enough protein, you do not gain as much muscle. That we know for sure. Okay. Well, if that's the case, then how much protein do we actually need? And that's why this study was so interesting, even though it's a small study, only 18 people. When they looked at 18 vegan men and they put them on the RDA for protein, they found that within 5 days, the vegan men were potentially starting to lose muscle because their nitrogen balance was negative. They were releasing more nitrogen than they were intaking. It means that something that the protein is being broken down and not being replaced, ergo, you could be losing muscle. But then we have to ask, well, how much protein do you need if the RDA is insufficient for men, and especially for those exercising? And then the flip side to that question, is too much protein actually bad for you? Well, this next study looked at high protein diets. So they said, okay, wait a minute, what if we just increase the protein really high, like 200 grams of protein a day or higher, and looked at what happens when you do that. So this study, called the low protein intake, is associated with a major reduction in IGF-1, cancer, and overall mortality in the 65 and younger, but not older population. So again, remember, once you get that 60 plus mark, you're actually going to probably need to increase your intake of protein in order to maintain muscle mass. And it does not seem to have a negative effect. But those who were under 65, look at the results on high protein intake. 75% increase in all causes of mortality. 400% increase in cancer death risk, not just getting cancer, but dying from cancer. And a 500% increase in diabetes. But the same report said, and I'll quote this right from the study, these associations were either abolished or at least attenuated if the proteins were plant-derived. Now, wait a minute. High protein plants, high protein animals, same amount of protein, drastically different results. Why is that? Well, let's dive into that for a second. Well, the animal proteins have different things in them. Animal proteins are higher in methionine and cysteine. Methionine are known to feed and potentiate cancer cells. You can even just Google search methionine-dependent cancers. There's about 14, 15 different cancers that actually depend on methionine. And the higher methionine you have running through your body, especially if it's excess methionine that your body doesn't need because it doesn't require it, you could be feeding cancer cells instead of feeding your healthy cells and stimulating the growth of methionine-dependent cancers, like breast cancer, prostate cancer, skin cancers, lung cancer is actually methionine dependent. Pancreatic cancer, the most lethal form of cancer there is out there. Higher IGF-1 increase. When you eat plants, it can actually reduce or bind the IGF-1, so it doesn't have the potential to feed cancer cells. Your body can unbind those things and release it what it needs, but binding those IGF-1 means that it can't be used by cancer cells. So there's a protective effect of IGF-1. You don't want to cause the cancer cells to grow because that's when they metastasize. And that's where 90% of cancer deaths come from, is metastasization of the cancers. Heme iron is present in animal products and animal proteins. It's not present at all. We know heme iron can lead to carcinogenic creation of N-nitroso compounds in the gut. We know this is clinically proven. Cholesterol and saturated fat, I won't even get into it because it's so controversial, but yes, those can be problems too. All of these things, high methionine is not generally found in most plant foods. IGF-1 increase is subdued by the amount of fiber intake that in plant-based diets. Heme iron is not present at all. Plants don't make it, so it can't happen. So you're getting a whole list of different pathways that the animal proteins are causing or feeding or accelerating the growth of these disease states that don't exist or are immolated by the plants when you consume them. So huge difference there. But let's get back to why the proteins at a higher amount in plants give you the same amount of muscle building and strength gaining effects. Okay. This is the methionine restriction diet that can actually control cancer. You can see here on the left-hand bottom side. And in humans, vegan diets, which can be low in methionine, actually be a nutritional strategy to prevent cancer growth and control cancer growth. All right. But let's get to the protein. That's the IGF-1 difference. That's the heme iron difference. And that's the cholesterol difference. But let's get to, oops, wrong slide. All right, let me just talk about it then. Okay, all right. So leucine. Leucine is one of the branched chain amino acids. So leucine is lower in plants than in animal products. Leucine stimulates muscle growth. So less animal protein will get you to what they call the leucine threshold. So the leucine threshold, let me see if I can actually, I'd have to import it. Okay, so the leucine threshold, let's see if I can. No, all right, I won't. The leucine threshold. So there is a window of leucine that stimulates mTOR and then stops. So any more leucine than that doesn't do anything. But you need to get to the maximum threshold in order to maximally stimulate that. The way to do that with plant proteins is to simply eat more plant protein. So a higher amount of plant protein may be required to get you to that maximum leucine threshold. Now, there is another way to do that. Instead of consuming more protein, you could just add the leucine, like in branched chain amino acids. And that's why I sell them, because I take branched chain amino acids. I can keep my protein intake a little lower by just adding that leucine and the branched chain amino acids. I am getting my body to that threshold, so I don't need to add a whole bunch of more protein, and I don't need to add a whole bunch more calories. This is how I can stay lean, but also keep the maximum amount of gains going to keep my body healthy. So this is one of the shortcuts that you can do. And you can either, one, eat more protein, plant protein, to compensate for the lower amounts of leucine and branched chain amino acids, or you could simply just take the branched chain amino acids and not have to consume that extra amounts of protein. So there you have it. You have an interesting study. Now, it's a very small study. It needs to be replicated. There are some interesting things about it. Within the study, it's the wrong one. Let's see if I can do share window. And share window. Okay. Let's take a look at the study here. So the current recommendation, the RDA, is 0.8. And I, like most other people, recommend closer to 1.2 to 1.6, especially if you're vegan and especially if you're an athlete, to get you to maximum amount, if that is your goal. If you're just about maintenance, you can probably get away with just 1 gram per kilogram of body weight. Now, there's per kilogram is 2.2 pounds. So you just need to do the math to translate it. When you looked at the study, that was 64 grams of protein in a 2,200 calorie diet. So that's what we are looking at here, is that you just need to add a little bit more protein throughout your day, get yourself to that maximum level, or add the branched chain amino acids so you don't have to consume so much more extra protein, and not worry about, if you are on a plant exclusive diet, not have to worry about the IGF-1, the heme iron, the extra cholesterol, all of those things that could lead to disease states. You can do this. You can reach your goals of gaining as much muscle as you want and maintaining it even at the age of 60 years of age and longer. Remember, once you get over 60, you have to bump up those protein levels, intakes a little bit more. And those eating a plant pure diet need to bump up your levels no matter what age you're at, just to try to compensate, or add your branched chain amino acids, and that way you don't have to consume quite as much. So that's my shortcut. That's one of the ways that I can maintain this physique naturally, completely drug-free, be vegan for almost 4 decades and still maintain a competition-ready body shape at 60 years of age by just doing it on plants and adding that supplemental nutrition so I don't have to consume all that extra calories. Now, if you look at it, it would make more sense if we were in nature, walking around the wild, scavenging for food all the time. We're burning calories, we're using up more. So consuming that extra protein with all those extra calories and sometimes a lot of the extra fat and carbohydrates and fiber that comes with it, that would be a lot. And you look at gorillas and they're eating it all day long. They're eating a ton and they've got big extended bellies. It's not a good look on human beings. It's not a preferred look for most people. So the way to get around that is simply to put the nutrients in there that will get you to the levels to maximally stimulate muscle growth. That way you can get the best results in the gym. You can eat a healthy diet, a healthy whole food plant-based diet, add the little bit of supplements that are in there, increase your protein intake slightly, manage them, and you can have the results you do without putting yourself in extended or exaggerated risks for certain disease states, which has been shown in the studies. I hope you enjoyed this study. I hope you enjoyed this. Now, it's a small study, needs to be replicated. There's a lot of things that I would change about it. Obviously, having a bigger study, having a better control group, looking at omnivore versus an isocaloric measurement, saying calorie to calorie, protein to protein, and then seeing what was happening. And it was only 5 days. It was a little bit concerning that 17 out of the 18 men that were in that in 5 days already were starting to lose muscle. That's a bit concerning, enough to want to share this study with you and say, hey guys, it's one thing, when you're out there touting a message saying, hey, where do I get enough protein? Yes, I get enough protein. Okay, that's a great thing, but let's be honest. And if you want to maintain that muscle and if you want to build muscle, you're going to have to make sure you got to give the body its building blocks that it needs. Yes, you can do it completely on a vegan diet. I've been vegan for 38 years. I do it. It can be done at any age. I'm 60 years of age. No excuses. There's ways to accomplish this without putting food in your body that can potentially lead to disease states. So there you go. I hope this is useful information. If you like it, please give it a thumbs up. Please share this video so we can get this information out to more people. I'm bringing you the best research that is new to the marketplace. I break it down for you in simple terms. I give you the links and all the stuff. So let me go ahead and just pull up the links here. This is a great study, Beyond the Zone Protein Needs for Active Individuals. Looking at that study, let's see if I can pull it up. Let me actually pull up this one first. There we go. And I will share this. So this was a high protein diet versus, so they looked at that and they found that if you are consuming 1.6 grams per kilogram a day, exclusively plant-based diet, this is quote, plant-based whole foods with soy protein isolate supplementation, they had no difference than protein matched mixed diet, which is mixed whole foods and whey protein supplement, in supporting muscle strength, muscle accrual, and suggesting that protein sources does not affect resistance training and adaptations in untrained young men consuming adequate amounts of protein. So getting that 1.6 grams of protein is important. Study after study, including this one, showed that there was no difference between eating a standard American diet, same calories, same amount of proteins, same results in muscle building. This one shows the same thing for endurance athletes after exercise. They found that 1.2 to 1.4 grams was sufficient for endurance athletes, but that was where they maintain muscle, maintain strength, even on a plant-based diet. So these studies, and of course, this study, the one in the Beyond Zone, the protein needs for this is all the way back in 2000. They were already looking at this and finding that just as long as you hit that 1.6 mark for active individuals, you are getting sufficient amounts of protein, regardless of the type of diet you're taking. So there you go. It's not so much about the source of protein, it's about the amount of protein and getting the right amounts for your goals. Look, if you're sedentary, if you're not active at all, yeah, you could probably get away with the 1 gram per kilogram of body weight, and that should be fine to meet your needs without losing muscle. Losing muscle also means losing strength. Frailty is important because as you age, if you lose your balance, you fall, or you find yourself weak and can't support yourself or something, you could lead to injury, broken bones, things like this. It does become very important. Keep your strength, maintain your strength, and you can maintain your physique too as well. I know I have. I enjoy it. So keep fit, keep healthy, do it the right way, stay clean, my friends. Thank you for joining me.